All right, exam 3, page 3. What you got for me? All right. So, problem number 9. David Akers, the kicker for the 49ers. How old is this test? Okay. I don't even know who David Akers is. Why am I pretending I care? All right, here we go. So, we are going to do this problem where we have a range, and it seems that we want to try to figure out the angle. So, you've got this V naught. So, we have R equals V naught squared times the sine of 2 times theta divided by G. And let me just go ahead and plug in some numbers here. So I'm going to get 28 squared times the sine of 2 times theta divided by 9.8 equals 70. Now there is one thing I want to do here. I'm going to go ahead, and when I simplify all these numbers, I'm going to end up getting the sine of 2 theta is 0.875. So the first thing I need to do is I need to do the inverse sine of 0.875. Let me just go ahead and do that. And I end up getting 60 degrees. And now I'm going to divide that by 2 to get 30. Now here's the thing. We look on here, 30 does not appear to be one of our choices. But we need to remember from the previous question that, actually not the previous question, one more page back, that in fact the complement of an angle also produces the same range. So when I go back here, I'm actually getting that 60 degrees is the correct answer. All right, moving on to number 10. We chuck this ball. What is the velocity? When is the velocity of the x component equal to 0? The answer, it turns out, because it's not accelerating, so not speeding up or slowing down in the x, is that one right there. Now we want to know when the velocity, the y component part of the velocity is 0. Well, it reaches a point right here, and it can't go any higher. Therefore, that is the correct answer. Then we want to know when the acceleration of the ball is equal to 0. Well, 9.8 meters per second is 9.8 meters per second squared. It's gravity that causes the acceleration. So it's never equal to 0. And, you know, I wanted to do number 13. So we want to know what would happen to the x component of this projectile if we were to fire it. And there are a couple of possibilities here. And it turns out, the way I've drawn it here, the correct answer would be C, if this is the velocity component, a constant positive velocity. But we actually ended up wiping out number 13 on our test. So we'll continue with the next set of problems.